The test? You don't? You turn around in a circle, it's 360?
Oh.
You would have figured it out eventually. You might have just not known it right away. That's okay. Okay, so 360 total, so you're going to want that there. Alright, we do have 5 kind of big ideas, and then we are going to do a couple examples. So central angle. A central, central angle is an angle with the vertex. Oh my goodness. At the center of the circle. Thanks. Sorry. Alright, so hence the word central angle. It's happening at the center. So as we take a look at this circle, there are 4 central angles. We have angle 1, angle 2, angle 3, and angle 4. We can name angles by using the numbers, if there's numbers, little numbers in the inside. We can also name angles using points. How many points do we need to use if we're going to name an angle with points? 3, good. Okay, when it traces it. This one we can't because there's not an inside point here. We would need a letter there to do that. For here. Alright, so in this case we would just name it angle 1, angle 2, angle 3, and angle 4. If we have an inside angle, then we could name it, which we'll see later on. Alright, an arc. An arc right there. Nope, just the paper. There you go. Super smart. All right, an arc is a part of the circumference. So remember, circumference is like the outside. And the way that we show an arc is we use kind of this, I don't know, an arc. Like this little curve on the top. If you put that little curve above some letters, that tells us it's an arc. Glue is right there if you want it. So it's a part of the circumference. We're following the outside edge of the circle. All right, so we have a couple things. We have minor arc, major arc, and a semicircle. Those are 3 classifications. We're going to be talking about arcs the whole time. So a minor arc, I'm going to use blue for minor. If you want to use blue, you can, or pick a color. It doesn't matter what color. It can be different than mine. All right, if something is minor, it's a minor detail. How big of a deal is it? It's not really, it's not big. Good. So minor means short or shortest. Path from point to point. So the shortest path from point to point. So when we go around in a circle, there's a long way and there's a short way. Okay, and often you guys deal with that at Apollo. When you're walking from class to class, you know that there's a short path and that there's a long path, right? Very rarely do you have a path where it's the same in both ways. So as we talk about minor arc, we're talking about the shortest path. So if I want to go from K to P, would the shortest path be going clockwise or going counterclockwise? Yeah, counterclockwise. This is shorter to go this direction, kind of to the right. So for minor arcs, arcs are similar to angles. We can use up to 3 letters. Hey, you two, focus. We can use up to 3 letters. We don't ever use more than 3. Okay, but we can also just do it with 2 letters. So here I can just name the beginning and the end. So the beginning is K, and the end is P. And then I put the little arc above it. If I only use 2 letters, that's telling me go as quick as you can. Start at K and go as quick as you can to P. It tells me go the short way. Okay. We can also do arcs with 3 letters. So this arc could also be K. It ends at P, but what's my middle stop? What letter am I going through? W. So either way would be the name for that blue arc, that minor arc that's less than halfway around. It's the fastest way. Usually for minor arcs, we use just 2 letters because it's quicker. Hi, right there, CJ, if you want to grab the paper. All right, so minor arc is the shortest path from point to point. What's a major arc? Longest, because if something is a major pain or a major deal, that's telling you it's a big deal. So major arc is the longest path from point to point. All right, so as we look at this again, we're going to do K to P, but this time I'm going to go the long way around. So K to P counterclockwise was the short way going down to the right. What would be the long way? Yeah, going the opposite direction, going clockwise, K up to P. Now, when I talk about a major arc, I can't just say KP. Because if I tell someone, quick, go K to P, they're going to go the quickest way. A major arc means we have to go around a longer way, so we always need to use 3 points. So again, we still use our beginning and our end. We start at K, we end at P. We could also start at P and go to K. But I need a middle point there. Where am I stopping through B? So K, B, P. Or you could also say P, B, K. Can go in either order, but B has to be that middle, and the end points have to be on the end. Okay, for a major arc, we must use 3 points. Always for a major arc, we must use 3 points. So that's an important note that sometimes people forget. You guys are crushing this. All right, next we got semicircle. What is a semicircle? What does that prefix semi mean? Half. Good. So semicircle is half of a circle. So semicircle is exactly halfway around the circle. I used red. So semicircle is exactly halfway across the circle. What is happening? So much in your brain some days. All right, so as I take a look at my circle, what 2 points are exactly halfway across from each other? B and W. So for my semicircle, if I don't care which way you're running, because no matter what, if you start at B and you end at W, is it the same distance? Yeah, it doesn't matter if you go clockwise or counterclockwise. If I don't care which direction you go in, I can just say B to W. I can just use 2 letters, saying we're starting at B, ending at W. But if I want you specifically to go in one direction, maybe one way has something you can drop off for me. I want you to go from my room to the gym, but on the way, I need you to drop off something in Mr. Pratt's room. Okay, then you have to go in that certain direction. So if I wanted to go this direction, B, P to W, I would need to use 3 letters to be specific. So I would say B, P, W. But as far as distance goes and length, that would technically be equal to the other way, B, K, W. Good. Hey, right there's the glue in. All right, we got one more thing, and then we are going to just talk a little bit. We have just a couple problems to go through. And this is going to be about arc length. So arc length is talking about how long you would actually run or how much you would measure around the outside. Remember yesterday we talked about the outside. What did we call the outside of a circle? Yeah, rather than like a perimeter, what did we call it? Right, we're going to use a number. A circumference. Okay, circumference is pi times diameter, or 2 pi r. Now this time, we're going to do the same idea. We're going to do pi times diameter, or 2 pi r, but we're not going the whole way. We're only going part of the way. So we use this cursive L for length. I don't know why. It's just what we do in math. A little loop-de-loop. Now I only want... What is happening? I only want the x degrees. So I'm going to say it's x out of, how many degrees is the total circle? 360. So that's going to tell me how much I want of the radius, or of the circumference. So 2 pi r after that. If you came in late, just copy what you can see and I'll open it up later. Okay, so length equals x over 360 times 2 pi r. Or we can say that the length is x over 360. What was our other formula for circumference? Instead of 2 pi r. Pi times d. What does d stand for again? Diameter. Good. All right, so we have 2 examples we're going to be looking through. We're going to be finding measurements. Remember this m, this lowercase m in front tells us to find the measure, and usually that means in degrees. So first thing we're going to find is the measure of angle HGI. So I'm going to just use a different color. Doesn't matter which color you use. I'm just using it to highlight at this point. H to G to I. So I'm trying to find this slice of the circle, how many degrees that is. What I know about the circle is that the whole thing is how much? 360. How much is half of the circle? 180. So from H all the way to J is 180 degrees. So if I know that H to J, half of it is 180. On the bottom part here, I know it's 128 degrees. How can I find the missing part? If I know together they make 180, one part is 128, how do I find the missing amount? Minus it. 180 minus 128. I'm going to use a handy dandy calculator because I don't left my phone at the desk. 180 minus 128. And we get 52. So angle of HGI is 52. And remember, our measurement is always in degrees, that little circle. All right, now it's asking me for HK. HK. So as I look at HK, it's only 2 letters. So it's telling me to start at H, end at K. Is it telling me to go around the right side of the triangle, clockwise? Or is it telling me to go the left side counterclockwise? Why is it telling me to go counterclockwise? It's telling me to go the longest way possible. Or sorry, shortest way possible. Thank you. Okay, now when it says measure of HK, it's really looking for that central angle. So we can really color this in. It's really looking for this amount. How am I going to find the amount that HK is? Couple ways we could do it. We know if I cover this up, now how many degrees is it from I to K? That's halfway, 180. And this part is 52, so how could I find that part? 180 minus 52, which will be 128. We also have these angles that are across from each other. Does anyone remember, what do we call angles across from each other? It's with a V. Vertical. Good. Vertical angles. Angles across from each other are vertical, which means that they are congruent. It's just if it's a straight line going through the middle. If it cuts it in half. But it has to be a straight line going through the middle. All right. HKI. I'm losing you guys. Come on. Here we go. H to K to I. So I'm going to start at H, going down to K, and I'm ending up at I. Couple ways we could do this one. I know H to K is how much? 128. Plus, how much will KJ be? 52. Plus J to I? 128. Some of you also might have looked at this and said this is 128, this is a half, so 128 plus 180. Or we could take the whole circle, 360, and take away the one part we aren't covering, which is the H to I part. I'm still going H to I, but I'm going the other way. So how much was this H to I? 52 degrees. So 360 minus 52. So lots of ways to get your answer there. Like I said, some people might do 128 plus 180. I personally would do this 128 plus 52 plus 128 because that's how my brain works. Either way, we get 308. All right, last one on this one. We're going to find the length of IJ. So to find the length, we have to use one of these formulas. So we're going to say cursive L equals. First thing we need is the X, the amount, the degrees. So when I look at I to J, it's the quickest way. It's the minor arc. How many degrees is I to J?
I to J? That's 128.
Good, 128 out of the whole circle, which is 360, times, now I need to decide if I'm going to do 2 pi r or pi times diameter. And this is where this GI is coming in. We've kind of ignored it for this whole time. GI, is that a radius or is GI a diameter? A radius. So because it's a radius, am I going to do 2 pi r or pi times diameter? 2 times pi times r. So 2 pi times, what's my r? 4. I'm going to throw that in my calculator. 128 divided by 360 times 2 pi. Don't forget to use that pi button. That will help get you the most accurate answer. Times 4. Okay, we're going to round to the nearest hundredth, 2 decimal places. So is it going to be 8 and 93 hundredths or 8 and 94 hundredths? 94, good. And what are we measuring it in? How was our length measured? It's good, centimeters. Okay, hi, you guys are stressing me out today. Just a lot going on right now. All right, here we go, last one. If you want to work ahead, if you feel like you kind of get the idea of this and you want to work through it, you kind of do your problem solving techniques here. All right, to start off with, we have GLK. So G to L over to K. Okay, a couple ways we could do it. One way, or the easiest way, would be to think vertical angles, angles that are across from each other, are congruent. Remember, those little arcs means they're the same, they match. So how many degrees is GLK? 59 degrees. If you did not know that for vertical angles, you could have used the idea that this is 180. Nope, you couldn't have done that. That's how you need to do that one. Got to do it that way. All right, HG. HG is telling me start at H, go as quick as you can to G. So if I start at H and I go quick as I can to G, am I going up to the right or down to the left? To the left. I'm going counterclockwise. And really what it's asking me here for is this angle. So since I don't have a vertical angle, the next thing I'm going to look for is that semicircle. Do I have a place where I can cut it in half? Yeah, where would I cut this in half? Sure, H to K. I know that this blue is how many degrees? 59. So how am I going to find the green? 180, half. So 180 minus 59. Okay, personally, when I cut my circle in half, I would have cut it in half this way. Just right down the middle and the up and down. But we would end up with the same thing, 180 minus 59. And we get 121. All right, next up we have IGK. IGK. So I'm starting at I, I'm going to K. Am I going to go to the right, clockwise, or to the left, counterclockwise? Why am I going left? Because I have to go to G. It says go from I to G, then end at K. So I'm counting that. Is that a major or a minor arc? Major. Major means it's over halfway. It's the long way around. So our answer for a major arc should be bigger than 180. All right, a couple ways to do this. One way is some people look at this. They say I to G is how many degrees? 180. And then I need to go how much more? 59 more. That's not how my brain works. My brain looks at all these pieces. They say there's 3 pieces. So I would do this 59 plus this green part, which is 121, plus this blue part, which is 59. So it's up to you on what your brain tells you to do. Some people can look at it segmented and just say, oh, that's 180 plus 59. My brain does not do that. It looks at all the parts individually. Either way, we're going to get the same answer, 239. All right, we got a little bit more work to do here. We got one more. We're doing the length. So length, remember, use that cursive L. It's a lowercase cursive L. Equals, and I need to have the degree out of 360. So in this one, I'm looking for HKJ. So I'm going from H down to K up to J. Do we know that amount yet? Do we? Do we know this amount over here, this KJ amount? No. How much is this IJ worth? It has this little box here, 90. So now if I'm missing just one part of the circle, what could I do? Subtract from... Sure, I could subtract from 180 and just do that side. Or I could do 360 minus 90 minus 59 minus 121 minus 59 and just subtract all of them and we get 31. Okay, hey guys, like 45 more seconds. You can do this. All right, so H to K to J. H to K is how much? HK? 180, it's halfway. So it's 180 plus another 31 degrees. I did this wrong last year. What's 180 plus 31? No, I did it right. 211. Okay, now for the rest of the formula, we're thinking, is this going to be pi times diameter or 2 pi r? You got it. So when I look at my measurement here, it's telling me HK. Is HK a radius or a diameter? Diameter. Good, it's the whole way across. H to K is the whole way across, so I'm going to use my pi times diameter. So pi times, what's my diameter? 12. Okay, throw that in the calculator. Abdurrahman Ibrahim? Do. All right, 2 decimal places. Is this going to be 22.09 or 22.10? What does that 5 tell me to do? To stay at the 9 or round up to 10? Round up to 10. So 22.10. When I write 10, do I need the extra 0? Nope, so just 22.1. All right, you guys were chit-chatty today, which is great. I'm glad